interval, or is that something different?
Nice, nice. No, it's exactly what that is.
Okay.
If it weren't descriptive, if it were inferential instead. How many of you guys have heard of the phrase confidence interval? I think I may have mentioned it in a quiz even with you guys. Yeah, a confidence interval is when you take the data from the sample and apply it to the population. Right now, I'm only looking at the sample itself.
Okay.
And but what you're saying is perfect, because the point of this study would be to apply it to a population. But I'm doing baby steps. Let's work on just the sample, and then as we develop the course, we'll develop how to take it out to the population.
Okay.
That's a great question. But it is, at heart, it's funny, because we were just doing this 3 hours ago in 244, building from this to the inferential model of it. But yeah, it's exactly what it is, Kelly. Very, very nice. Shoes. Number 2, x bar minus 2s and x bar plus 2s is called 2 standard deviation. I think you can see where we're going with this. This can be repeated ad nauseum as far as you want to go. You can also, you don't have to go out whole numbers of standard deviation. You can go out half standard deviation if you want. You can go out fractional standard deviations. You can go out decimal standard. But generally, the way this is kind of laid out is 1 and 2 and 3 and so forth and so on. So basically, you take the number s and add and subtract some multiple of it from average. And whatever multiple you use is the number of standard deviations you've gone out.
Okay.
Is that definition okay? That's just we're kind of saddled with that definition historically. So, ask me questions if that doesn't make sense. Please ask me if we're not entirely sure about that. I love the way Kelly brought up confidence intervals. Sometimes you'll see this written like a confidence interval, or it'll be written like this: x bar plus or minus 2 s's. Sometimes you'll see that written plus or minus, and it just realize it does represent a range of values. So x bar minus to x bar plus s is everywhere from -15 up to, -31 up to 1. So swinging the camera back to the graph, that whole range is 1 standard deviation. This whole range is 2 standard deviations. Somebody in class yesterday asked, what about 5 standard deviations? You can go there. You totally can, right? You could drop 80 pounds, because 5 of these would be 80. You can drop 80 pounds from average, then you'd be down at -95. And you could add 80 pounds, and you'd be +75, and you could say between -85 and +75. I'm not sure we'd want to do that, because I think you'd kill people if you started doing that over the course of a weight loss study. But nonetheless, for manufacturing, 5 standard deviations is not going to be that wide. It'll be much, much, much tighter. Going back to Candace's 2 variable or not so variable. Please, Lloyd.
Why would you use the difference?
Love this. Why? That is the best question, right? Okay, you taught me this great definition, Sean, that's apparently been around for 100 years, that was invented by someone at some point, somewhere. Who cares? Good. First thing I want you guys to check. Take your raw data again, although in general you won't have this raw data. You won't have this raw data. What I want you to do right now is go into this raw data and figure out how many of our folks are within that first standard deviation. Figure out how many of our folks fell within that first standard deviation. Let me turn this off. Let's slide out of the way. Yeah, Lloyd, great question. This is a fantastic question. Why do we care? Yes, why do we care? Let me kill the camera, save some battery. We'll come